Yeah, let's go ahead. Let's go ahead and get the road under the show.
All right, we are recording.
Okay. Hello, everyone. I'm Gordon Rosner, your president, and welcome to the November General Meeting. Here's the agenda for tonight. As usual, we'll have a welcome and we'll have introductions where I always uh, list everybody who is on our leadership team. But now is our officer election. So this meeting actually is the election of our officers. We've been talking about this for the last couple months or so. So we're down on it right now. Tonight is voting time for those club members. We'll go into some club news. And our main presentation is by Jeff Kanipe, a science journalist and author, many astronomy books. I bet most of you will recognize him. And look at that, Peculiar Galaxies. I'll be talking about those. So he fits right in, right, with peculiarities. So again, welcome everyone. Live long and prosper. By the way, talking about prosper, I have to bring up the eclipse early in the morning. Our Facebook page, in which we have over 700 members, East Valley Astronomy Club is our Facebook page. Over 700 members, and they've been taking some fantastic pictures. They got up early in the morning and practiced their art and their science, and wow, you guys, everyone should go in our Facebook page and look at some of these. I mean, uh, Joanne and Kevin and Cindy and Tom and Rick and Bruce and Steve and Alice and Wallace and Keith and Paul and Leo and Luke, they've all submitted pictures of their art and their science. So, and it keeps on going. Every time I look in, there's someone new adds their picture. So take a look, everybody, and see what our club members and our club guests are doing and what they did this early this morning. So introductions. I always put this up just to remind everybody what the club's leadership team is. Now, those people on the left side of the screen are those that are elected. Those people on the right, administrators, they're assigned with approval from the entire board of directors. All right, so for instance, Claude is our Greco manager. He was assigned, and I'm the outreach manager. James Yoder, property manager. Marty, Wayne, and Brooks are all assigned to those positions. They volunteered for it, and then the board approves them. Whereas those people on the left side, they are actually elected every year by the membership, and that's what we're going to be doing tonight. But down there at the bottom, I always say the most important member of the club is you. Without you, there would be no list. So we'll get into officer elections. We didn't receive enough volunteers who offered to fill the open positions with new people. So most of our current officers agreed to fill the open positions for another year. That was a concern because that would mean that people were in the same positions, the same leadership positions for 3 years. And we really should mix it up. That's why we have elections every year, get new people involved, switch around, that kind of thing. We don't want to have the same people in the same offices year after year after year. But in this case, what we did, since we really didn't have enough volunteers, is the officers agreed that they would kind of shuffle around and take different positions. So after shaking that box, the position of vice president remained open. And we'll talk a little bit about that in a bit. No big deal. We'll talk about it. The VP is going to remain open, but anyone interested can apply for that position at any time during the year. And that certainly is encouraged. So general membership must agree with this plan because there really is no election. There is no group of people in which the general membership would say, yes, I vote for this person here and that person there and that person there. We only have one person in each position. In fact, we're shy that vice president position. But we need to vote on it so the membership can agree that for next year, these are the leadership positions and how they'll stand. So in the chat function, either at the bottom or the top, what you can do is either vote yes or no on yes, I agree with these people doing this, or no, there is some problem. You know, I'm sick of seeing Gordon's face. I don't want him anywhere. You know, whatever. What you can do is when you're in the chat, there's two buttons you can press. You can press just the panelists, which are those officers, or everyone. So it's up to you, whichever one you want to do. We simply just need a yes or a no. So this is how the box shook out. President Claude Haynes, we all know Claude. He has been a past president. He has filled many leadership positions. He's currently the manager of our Greco Observatory. He's been that for many years now. The vice president is open. We'll get back to that in a minute. Our treasurer, Alex Nachman, we're all familiar with her. She was a board member at large and now is running, I guess you would say, for our treasurer position. And remember, Alex, a lot of confidence in her. She was the president, or actually in this case, the chairman is what it's called, of the South Mountain Astronomy Club until it was closed down because of the area that they held their meetings was not funded anymore by the city. Secretary is me. Board members at large. We did have a new person come on up and said, yeah, I want to be a part of this great club. David Kosho. Now, y'all should remember David. He held leadership positions before. He was the Greco manager before Claude took over. And John and Bill are current board members at large who agreed that they would stay on in their positions. Brooke Schofield, our treasurer, agreed to move over to a board member at large and let someone else take that over, of which Alex agreed to do that. And Derek Youngson, he agreed to continue on as a board member at large. So let's talk about vice president, our open position. Now it's like, you know, some people have asked me, well, Gordon, why didn't you fill that position? Well, if I filled that position, the secretary position would be open. And the thought is that we need someone, a named person in the secretary's seat. Because the secretary takes notes, maintains the notes, maintains the documentation of the club. So we can't have that spread around with different people. The vice president, however, can be supported, the duties can be supported and accomplished by other people collectively. Tom Marsden, who currently is the vice president, you don't see him on this list because he now is able to help out wherever he can rather than having a specific role. So he will help us with the vice president. Wayne is in the same way. He can help us out. He's so involved with asteroid occultations that he's going to focus on that, but he will help us out also. So that's why vice president position remains open, because it can be filled by the collective team. So officer elections, remember all EVAC members, please vote yes or no via the Zoom screen, that chat button. Okay, and I'll keep track. And at the end of the meeting, I'll let everybody know. However, officially, the results are going to be included in December's club newsletter. So club news, Greco remains open for private star parties. That has been going so well. It's amazing how Claude can keep that going, because it seems like every night he's got a few people in there. Same thing as always, you go on the website. It's limited to just a few people, 4, 5, 6 people like that. And you have to get on the schedule. And you do that by going to the Greco site on the EVAC website, the Greco page, I should say, on the EVAC website. Greco has been open to the public on Saturday evenings. And we talked about this last month, is that what we want to do is preparing to open up, completely open up. We kind of been only going Saturday evenings, letting the general public come in, getting their input, seeing how our safety measures work. So we're doing that on Saturdays. So some of you may be surprised on a Saturday, walk by Greco, and here it is open when, wow, I thought it was closed. However, due to the Riparian After Dark event, the Riparian is the area, it's like a park, a huge park, which our observatory is located in. It's not even located at the highest point of the park, but does a great job. That event and the holidays, Greco will not be open to the public on the Saturdays between December 11th and through January the 1st. So remember that. If you're going by thinking that's going to be open on those Saturdays, we're not too, there's too much going on around us. Club news are the usual club olds. You know, all the other personal contact events, they all remain closed. Boy, we were hoping to be open by now, but the board of directors decided that let's push that off, and we will reconvene at least January and then determine what our forward approach is. Member articles, hey, people, if you got any kind of member article talking about your adventures, send them to me, and we'll include them in the newsletter, which a few of you now have done. So appreciate that. Keep those coming. And remember that our monthly meetings are being recorded just as usual. So our next EVAC meeting is on Friday, the 17th December, usual time. However, it's the last meeting of the year, and we usually have a holiday party during that time. But with the pandemic, just like last year, we're not going to get together. But because of that, we have a special meeting lined up, doing something special for the holiday, right? So we will not have a main speaker, but instead we'll use this time for a few member presentations. So if you would like to make a presentation about your astronomy adventure, but you're always kind of sitting back and going, man, our main speakers, they are up there. I mean, they are top level professional astronomy people known across the industry. And, you know, me going in there and giving my little thing, well, maybe I feel a little intimidated about that. So if you always wanted to, come on, let me know. And we'll get you in, and we'll review your presentation just to make sure that everything's okay with it. And you can be amongst other people who are giving these short 10-minute or so presentations of just the club members and anyone outside of the club who wants to give a little 10-minute presentation. You don't have to be a club member to do this, but anyone who has been involved with these presentations, who have watched, and you've got something, 10 minutes or so, yeah, let me know. And how do you let me know? You go into the EVAC website at the bottom of the first page. It's Contact President. Type a little bit in there on what you're thinking on doing, and it comes directly to me, and I will get back with you. So that's our special, is it's just about us now. So, yeah, if you've been wanting to, now's the opportunity to give it, and to give it amongst us friends, right? So just let me know at the President's link at the bottom of the main page. So that next EVAC meeting is on Friday, the 17th of December. So don't miss that one. So hopefully we'll have quite a few people giving these short presentations, and who knows what it is. They'll, as they come on in, heck, who knows? That'll be the fun of it. So join in on the online fun. Remember, people, is that vote yes or no via the chat function now. Now, during this meeting, after the meeting is open, the voting will be closed. So remember now, Claude for president, we all know Claude, vice president is open. You can always volunteer if you want to fill that position. Treasurer is Alex, Secretary is me, board members, David, John, Bill, Brooks, Derek. If you agree the way this box shook itself out, and to make sure that we didn't have the exact same people in these main administrative officer positions, this is our plan, but we need your vote. Vote yes or no. If you're a member, you have to be a EVAC member to be able to vote. Let us know, and then it'll be in the December newsletter. So now our main presentation, Jeff Kanipe. I will hand this over to our current Vice President, Tom Mosden, who will introduce Jeff, and we'll get on with his presentation.
Thank you, Gordon. Yeah, it's my pleasure to introduce Jeff Kanipe. He's been a science journalist for over 35 years, specializing in cosmology and astrophysics. He's the author of the popular series Annals of the Deep Sky, a survey of galactic and extragalactic objects, which is now being published by the American Astronomical Society and Sky and Telescope. Annals is an up-to-date observing manual for amateur and semi-pro astronomers, which features in-depth astrophysical profiles of stars and non-stellar objects, historical and biographical backgrounds, as well as observing advice for amateur astronomers of all expertise. Volumes 1 through 3 received rave reviews 5 years ago, and he's finished all the volumes up to 8. 8 is currently available, and volumes 9, 10, and 11 are in the works and should be out in the near future. And when completed, the series will comprise all 88 constellations. There'll be quite a nice collection there. And Jeff's also the author of Chasing Hubble's Shadows, The Search for Galaxies at the Edge of Time, The Cosmic Connection, How Astronomical Events Impact Life on Earth, and The Skywatcher's Year. He's a co-author of the Atlas of Peculiar Galaxies, a Chronicle and Observer's Guide, co-authored with Dennis Webb, and also Island on Fire, co-author with his wife, science writer Alexandra Whitsey. He's also worked as a top editor for both Astronomy and Stardate magazines and written for numerous publications, including New Scientist, Nature, and Sky and Telescope. And for icing on the cake, Jeff has an asteroid named after him, 84447 Jeff Kanipe. So I'll stop talking and let our main speaker give you the presentation. Welcome, Jeff.
Thank you.
Just a tech check. Are you able to see the screen?
Yes, it's great.
Great, you're on.
Okay. Thanks, Tom. What do we got there? Okay. Anyway, I'm happy and honored to be here with the members of the East Valley Astronomy Club. You guys sound like a really active and vibrant club, and that's really good. It's good for business, so keep up the good work. So as has been mentioned, I am the author, believe it or not, of the Annals of the Deep Sky. But rather than drone on about the book, I thought that I'd share something I've learned over the course of writing the series. Actually, something that impressed me back when I was writing the ARP Atlas of Peculiar Galaxies. And we can talk more about the Annals and its future in the Q&A if you like. But tonight's subject is one that's near and dear to my heart: peculiar galaxies. Peculiar describes me as much as anybody else, I suppose. But peculiar galaxies is always something that has attracted me. More specifically, what makes a peculiar galaxy peculiar? These disturbed systems, who Edwin Hubble referred to as irregulars, have a rich revelatory history in galactic dynamics. And ironically, while they were once estimated to make up only 2 or 3% of the population of known galaxies, one may argue that peculiars are now in the majority, especially when you consider those galaxies dwelling in the very early universe. But the thing is you can't really call them peculiar anymore, because for the most part, astrophysicists know why peculiar galaxies look the way they do. the concept of what a galaxy is did not begin to emerge in scientific terms until about 1925, when Edwin Hubble demonstrated that spiral nebulae, as they were called, even into the 1960s, were not constituents of our Milky Way, but vast stellar systems lying far beyond our own galaxy. Now, the term galaxy did not come into the literature until 1929, and the person who used that term most frequently was Harlow Shapley, who only 9 years before had argued that spiral nebulae were merely nearby gas clouds in the Milky Way. So you see, scientists can be wrong, but they can also course correct when newer facts are presented. After all, Shapley could have continued sticking to his claim that spiral nebulae were constituents of the Milky Way, but I suspect his career would not have ended well. Which brings me to Alton Arp, an observational astronomer who for 28 years worked at Mount Palomar and Mount Wilson observatories. He is famous, of course, for his discordant redshift theory, which sought to explain or find evidence for unusually high numbers of high redshift objects like quasars and emission line objects parked near or aligned with low redshift galaxies. Now, I want to make it clear that I'm not here to diss Arp, because while writing my book, The Arp Atlas of Peculiar Galaxies, I got to know him pretty well and found him extremely likable. And no matter what you think of the guy, you can't deny that he did a lot of pioneering work in astronomy in the 1950s and 60s. He was the first one to study the blue globular clusters in the Magellanic Clouds. He published many papers on nebulae, novae, star clusters, and of course, there is his legacy, the Atlas of Peculiar Galaxies. Now, while on staff for Caltech, he compiled his atlas in 1961, at the young age of 34. And here we see a young Arp posed uncomfortably, I think, at the 200-inch Cassegrain image intensifier spectrograph. You might be interested in knowing that Arp was very happy with our book. And in a February 2007 email to me, he wrote, "I have been writing a memoir of sorts, and my first reaction was, well, he has done it all much better than I could have. But then I realized you have freed me to go deeper into the consequences of what happened and explore connections on broader scientific and human scale." Now, as far as I know, no such memoir is forthcoming, but whether one eventually surfaces, there is no doubt that he left an indelible mark on the study of galaxies. Now, the term peculiar galaxy was bandied about at the turn of the century. There were peculiar meteors or peculiar lights on the moon, and there were papers about these things. But the term peculiar galaxy did not enter the formal literature until the late 1960s. Oh, the study of these freakish things, or perhaps I should say their gradual amassing in atlases and catalogs, had been conducted since the late 1950s, almost single-handedly by this guy, Russian astronomer Boris Vorontsov-Yamanov. I just love saying that name. He compiled a catalog of what are now known as Vorontsov-Yamanov galaxies in the Atlas and Catalog of Interacting Galaxies, as well as his larger and more general morphological catalog of galaxies. So the study of normal galaxies was the prime directive among astronomers during the first half of the 20th century. Galaxies are new. We have to find out what they're all about. What is it? What's their nature? But that was a difficult thing to do with this guy around, Alan Sandage. He was one of the most prolific astronomers involved with classifying galaxies in the late 1950s. And after all, he'd worked alongside Hubble himself. And years after Hubble's death in September 1953, he was still carrying a torch for the venerated astronomer and did so until his death in 2010. But during his prime, Sandage virtually took over the universe on Palomar Mountain. Not only was he doing galaxy classification, but he was also doing globular clusters, Cepheids, the cosmological distance scale, the Magellanic Clouds, and the Virgo cluster, to name a few. He just outworked and outdistanced everybody. And his contributions to astrophysics and cosmology were impressively foundational. But Arp didn't have a hope in heck of sharing the research spotlight with Sandage. The only thing left for him to do was what Alan Sandage would never do. and that was peer inside the cabinet of peculiar galaxies to see what was within. The result was ARP's Atlas of Peculiar Galaxies. So here we have a peek of the atlas, which I actually own a copy. If I were with you, I'd pass it around. We all look at it. But the atlas depicts 338 galaxies and galaxy systems that you cannot shoehorn into any conventional galaxy classification scheme. Barry Mador, whom some of you may know, would later work with ARP on the Southern Atlas of Peculiar Galaxies, told me that seeing the atlas for the first time was quite a revelation. Can you imagine? Here's an astronomer who's seeing galaxies that are just normal spirals, all symmetrical. And then one day this atlas arrives in the library at the observatory, and they go down and see these things. He told me everybody had grown up and been fed by the story of by Hubble and Sandage, that the vast majority of galaxies were beautiful, textbook, and symmetric. But to suddenly to be exposed to all of these pathological strange objects was fascinating. It wasn't clear what to do with them. And I'll repeat that last line again. It wasn't clear what to do with them. And for a long time, nobody knew what to do with them. So here's a peek inside the atlas. And these photographs, by the way, in fact, the tadpole is at the lower left, 188. These photographs are actually gummed in on the page. So it is sort of like each photo, like looking at a scrapbook, photographic scrapbook. Very unique. Well, in the 1950s and 60s, those were the days, weren't they? Astronomers didn't use terms like galactic collisions or interactions, much less mergers. The thinking then was that galaxies were so small and the space between them so great, it would be unlikely to catch a collision in the act. As for those few anomalous galaxies, the uncanny ones with bridges, tails, warped disks, blown out centers, etc., they were essentially ignored. After all such forms could not be categorized and classified using conventional galaxy classification schemes, like the ones devised by Hubble, Sandage, and Gerard de Vaucouleurs. Their schemes employed all manner of configurations to get the point across, from tuning forks and footballs to wheels and elaborate schematics. But the idea that peculiar galaxies could be related to galaxy interactions or mergers rarely, if ever, entered their minds. De Vaucouleurs, though, to his credit, would later incorporate galactic interactions in his morphological stratagems. Nevertheless, there were some visionaries who investigated the possibility that galaxy interactions were at the bottom of some unusual galactic forms. As far back as 1941, Swedish astronomer Eric Holmberg published a paper on tidal disturbances that might arise between two hypothetically interacting galaxies. And he demonstrated this using, of all things, an ingenious analog computer constructed of 74 light bulbs in two groups of 37, and each bulb representing the various mass elements. The results were impressive, but not convincing enough to conventional astronomers anyway. And here we see the two galaxies on the left here approaching each other, and on the right side is Holmberg's result. Then in the early 1970s, Allard and Jurie Toumre started cranking out numeric models that came closer to reality than anything before. And here they simulated an encounter between M51 and its satellite, NGC 5195, and I'm sure most of you have seen in telescopes many times. This combined view shows the system as it appears nearly face on, and that's at lower left, edge on in the middle, and a side view with a slight inclination top. It was computer models like these that demonstrated that tidal forces in slow, near passages of galaxies of near equal mass not only draw out extended tails of material, but also funnel a large fraction of the gas toward the center of each galaxy. Even more impressive was the fact that the Toumre's numerical simulations could be applied to real galaxies. This animation shows how far astrophysicists have come in simulating galactic collisions and mergers that reflect real galaxies. First up is ARP 302, a pair of gas-rich spiral galaxies and booties that are in the very early stages of an interaction. In fact, their disks are just beginning to come in contact. Next is ARP 148, aka Mayall's object, located in Ursa Major. This represents a collision between two parent galaxies. The resulting shockwave has created a starburst ring, and we see it now as a ring-shaped galaxy with a long-tailed companion. ESO 7714 represents a gravitational tug-of-war between two galaxies, as is apparent with the bridge of material connecting them. This system is in the constellation Indus. Next up is VV705, aka Markarian 848, also in Bootes. It consists of two galaxies that are midway through a merger. We see two long plumes of gas and stars emerging from a central region with two close-knit cores. And finally, ESO 148T2 consists of a pair of former disk galaxies undergoing a collision. The cores of the galaxies are embedded in hot dust and contain millions of stars, and this one is in Tucana. So we ask ourselves, again, what makes a peculiar galaxy peculiar? The chief causes are flybys, harassments, interactions, or mergers with another galaxy or galaxies. Sometimes all four phenomena are at play. And as I'll show you later, there are, of course, other possibilities inherent with the galaxy itself that can make it peculiar, but interactions and flybys are the primary movers. This is Artmador 1914. It's an example of galactic harassment. Like ants, galaxies are generally not found in isolation. Most are surrounded by a swarm of satellite galaxies and are often embedded in larger aggregates, such as galaxy groups or clusters. In these environments, interactions between galaxies are common and in general can be divided into two basic types: mergers and flybys. Interactions involving high-speed flybys are referred to as galaxy harassment, and that's what we're seeing here. Harassment may disturb or even radically change the morphologies of the galaxies involved, resulting in asymmetrical disks, warps, bars, and tidal tails. The Cartwheel Galaxy is one that has recently been harassed, and we see the results here. It was discovered by Fritz Zwicky, that curmudgeon, in 1941. And at the time, and he considered it to be one of the most complicated structures awaiting its explanation on the basis of stellar dynamics. Quote, the outer starburst ring is the result of a shock wave created by another galaxy rapidly passing through the center of what was once a normal spiral galaxy. The three companions are G1, is a Magellanic type, G2, a yellow compact spiral, and G3, spiral galaxy that is often just outside the popular image frame of the Cartwheel system. Its trail of neutral hydrogen betrays it as the bullet galaxy that struck the Cartwheel before moving on. Interloping galaxies, in fact, are often identified by their neutral hydrogen tracks, leading away from the disturbed galaxy like footprints in the snow. Galaxies can be peculiar for other reasons. One good example is M82, which is exploding with runaway star formation. This composite image captures light from visible and infrared wavelengths, as well as light from the hydrogen fountains expelled in the starburst activity. At the same time, the robust star-making machinery in M82 is also attributable to an interaction with a nearby spiral, M81. And here's a surprising flip to galaxy interactions. Highly symmetric spirals, like M81, can also form when a galaxy is strongly perturbed by a close encounter with another galaxy, in this case, M82. Now, this mechanism was illustrated in ARP's Atlas of Peculiar Galaxies and modeled by the Toomre brothers. Tidal forces during an encounter can perturb the stars so much that their previously nearly circular orbits become elongated, especially in the outer parts. And that's what we see here with M81. And galactic shear can force regions at different radii to rotate at different rates, causing the stars to bunch together in a symmetric spiral pattern. Peculiar galaxies may also exhibit anomalous structures, like this jet in ARP 192. At left is the Atlas image of ARP 192. And at right is a more recent image. And note that in the right image, the jet is missing. Why is this? It's an interesting story. In this case, the jet was an asteroid that happened to track through the bulbous head of the galaxy when ARP made his exposure back in 1965. The track does not look perfectly straight, but seems to be curved. And this caused some confusion and led them to think that it was a natural part of this galaxy, a natural structure. As I said, it's an interesting story, and you can ask me about it in the Q&A. Moving on, shell and arc structures are also considered features of perturbed galaxies. There are two scenarios for producing galactic arcs from mergers: phase wrapping and spatial wrapping. Time prevents me from explaining each in detail, but suffice it to say that both involve two galaxies merging and causing their stars to slosh around in the gravitational potential depending on their orbital periods, which are modified in different ways by the merger. For more, you can see the ARP Atlas of Peculiar Galaxies right here, page 190. Okay, so let's review for a moment. Insofar as classifying galaxies is concerned, we start out with the Hubble-Divalcourt scheme, still used by many astronomers today, mainly in university teaching classes. But classification schemes like these are based on symmetry, not departures from symmetry, and an almost obsessive, compulsive desire to make things neat, like organizing a junk drawer. But how do such schemes apply to galaxies like these? Where on the Hubble tuning fork are you going to put these galaxies? The range of peculiar morphologies is seemingly endless. Not one looks like the other, but we still recognize them as galaxies because they exhibit some of the familiar forms of galaxies. And yet they don't. Perhaps it's time we stop treating such galaxies as peculiar and start treating them for what they are, galaxies. After all, medical science has whole fields dedicated to understanding fetal and childhood deformities, but they are still studying human beings. Even the Andromeda Galaxy, often held up as a normal spiral galaxy, has some unusual features, such as a warped outer ring, small inner dust ring offset from the nucleus, and a very curious core that comprises two brightness peaks, which are likely the result of a supermassive black hole. Multi-wavelength observations of galaxies have radically changed the way we think about galactic morphology. And here are two faces of M100 seen at the same approximate scale. This galaxy is often considered a normal spiral, even a Milky Way analog, although it is twice as large. The Spitzer image on the left contains many filamentary regions distributed throughout the disk. But note the infrared pockets spaced apart at approximately equal distances and similar magnitudes. These infrared substructures are not evident in the optical bands seen on the right. In the Hubble Atlas of Galaxies, Alan Sandage classified this galaxy as a simple SC, In other words, a spiral galaxy with widely splayed arms. The NASA Extragalactic Database classifies it as an SABSBC, which is an S-shaped intermediate barred spiral galaxy. Now, although the second classification takes in greater morphological detail, does it still work for this galaxy's appearance in the infrared? Here we see NGC 300 in optical, infrared, and ultraviolet. Edwin Hubble and other pioneering galaxy morphologists were focused on classifying galaxies at optical wavelengths. One might argue that the optical and UV images of NGC 300 resemble each other, sort of. But what about its appearance in the infrared? It's virtually unrecognizable. Given these insights, what does galaxy classification really accomplish? As Barry Medor said to me in a 2006 interview, considering the wide range of perturbed morphological forms, we might as well classify turbulent eddies and ocean waves. Another even more serious issue is raised by galaxies twisted up in a gravitational lens. And even at optical wavelengths, all bets are off. This formation is in Fornax. And I think it's apparent that conventional morphological classification is out the window for things like this. What we have here are spiral galaxies torqued up in an Einstein ring, one of the largest and nearly perfect rings known. So here we are faced with an entirely different morphological paradigm. Now, all this is just to say that up to a point, we can argue that galaxy classification gives you a common language to describe some galaxies as we see them, particularly in the local universe and the nearby universe. But in the end, it can't take you anywhere. Even if we stick just with their optical appearances, you can't get around the fact that galaxies are simply pictures of huge structures frozen in time. They don't look like what they used to look like, probably don't look like they do now, and certainly won't resemble their present morphological form in future cosmological epochs. Well, I think I've gone on long enough. It's time for me to move on to the conclusion, which is quite simple. You'll be relieved to know. Nothing about galaxies can be considered normal. Like snowflakes, turbulent eddies, ocean waves, each are unique when looked at closely enough. And they are ephemeral because even though they exist on astronomical timescales and seem frozen to us, they do not exist forever in their present forms. They evolve and change with time. And we know from computer models that a merger between two spirals will likely result in a single elliptical galaxy. But that is about all we know with any confidence. What will galaxies in the Hubble Ultra Deep Field look like in another 2 or 3 billion years? How did they look coming out of the chute of the Big Bang? In order to answer such questions, we need to know a heck of a lot more about the nature of all galaxies near and far, not just a handful, and not just the symmetrical few. Before 1925, astronomers considered the universe to be about 300,000 light years across. Then on New Year's Day, 1925, Edwin Hubble showed that, in fact, spiral nebulae were independent star systems located at distances that were unimaginable. I think that moment was the starting gun for modern galactic research. And if you think about it, the field is only 96 years old. While astronomers now understand far more about galaxies than they did a century ago, there's still a long way to go, and many exciting discoveries, I think, are in the offing. And I just say that there's still a long way to go with Annals of the Deep Sky, too. Though we are nearly halfway there with over 500,000 words written. I'm giving War and Peace a run for its money. I plan to keep working on the series And now that we have a new injection of production energy with the AAS and Sky and Telescope, the series can only get better, as you will see. And I can tell you that I've completed volumes 9, 10, and 11. I completed volume 11, in fact, yesterday. And I can promise you that more cool stuff is coming, so stay tuned. And that's my presentation. Thank you. And I will be open for questions.
I'm going to stop the sharing.
Thank you, Jeff. That was wonderful.
Thank you.
So you're on
So if people want to have comments or questions, please put them in the Q&A. As those are building, Jeff, Tony George mentioned that in about 4 years from now, there'll be an occultation of your asteroid in the Phoenix
really?
area.
I look forward to it.
It's gonna be a fast one, 0.2 seconds.
Ooh.
But I'll bet you the guys will bag it.
I bet. I've been trying to decide how to image the thing. I think I'm going to have to go to a private observatory and see if someone can image it for me.
Yeah. Okay. Let's see. I'm gonna put Brooks on. Let's get to Brooks. Sorry, I'm a little.
difficult for me to get back to your presentation, so I don't know how to show the slide.
Oh, well.
Okay.
Participants. Oh, there we go. So, Brooks, oops.
This person wants to-
Okay,
There you
Goodbye.
go.
there I go. Actually, I was at our observatory last Saturday, and a person going through there asked me a very, very basic question, which I really could not answer. I know there's a definition for planet, size, mass, clears its own area, but is there a definition for galaxy? And if so, what is it?
Well, that's an interesting question. Galaxies are something that have a wide range of sizes. And in fact, globular clusters, some globular clusters, large ones, are on the verge of being the nuclei of former galaxies themselves. So while we can easily, calmly, and confidently say something like M31 is a galaxy, and we can say the Magellanic Clouds are galaxies, when you get into smaller regimes, it's a little dicier. And because of the discoveries that are coming so fast, there are many smaller dwarf spheroidal, that's hard to say, galaxies, that the line between globular clusters and galaxies is sort of blurred. But there is the traditional definition is it's a star system that has its own stars, its own orbits, and its own self-identity. I don't know if that helps at all, but
Well, I feel a lot better, and that is approximately the answer I gave.
Yeah.
Which is, especially you start looking at the larger globular clusters, probably
Yeah.
the standout difference is there's no gas associated with it. It's all over.
Right. And the thing is that some of these globulars, like Centaurus A, have trails that they leave star streams behind them in their orbits, which implies that they were in orbit or perhaps, came near our galaxy and then it was captured. So, I mean, yeah, it's a fine line. And astronomers, it's funny, they're still arguing about it.
Well, thank you very much.
Yes, sir, Brooks.
Okay, next question's from Alex. And Alex, you might want to comment on your chat comment also. So.
All right. Can you hear me okay?
Yes, I can.
All right, cool. So I left a comment saying that I absolutely love peculiar galaxies. They're
Yes.
actually some of the first galaxies that I ever processed with data from the Hubble Space Telescope. So it was really cool to like learn how to do image processing using those images. And a little fun aside is that I like to spell the word galaxy with an E to kind of make a play on my name.
Okay.
So I was like, oh, that's so cool that my name is Alex and it's in the word galaxy. So
It is. I never thought about that. So what
Yeah.
did you do? What did you do with your work? Did you publish it or just use it as processing?
Yeah, I do it mostly kind of for fun and post it on like social media like Instagram or Facebook. And it ended up kind of turning into like this educational thing where I got to kind of reach out to people and connect with them through my images of like galaxies or nebula, all with data from the Hubble Space Telescope.
Wow, that's great. Well, you should send me some of your images because I'm always on the lookout for images for the series.
Yeah, so I was actually wondering, where can you buy your books?
Sorry. Yeah.
You know the URL.
The URL is shopatsky.com. That's Sky and Telescope. That's where the books are now. You know,
Yes.
we lived here in limbo for a year, not knowing where they were. In fact, I just learned today that volume 8 was on a garage floor, sitting there on a pallet for a whole year. But now that the American Astronomical Society and Sky and Telescope have come on board, and they are now selling the books at shopatsky.com.
Ooh, all right. I will definitely check that out.
Yeah, great. Bye.
No, thanks, Alex. Bob has a question. Bob, your
I'm
mic
here.
is-
You showed that picture of a peculiar galaxy that had a little spike coming out of it, which you said was an asteroid trail,
Yeah,
and that there was a story. I'd love to hear the story.
I'll be happy to tell you about it. When we published our book, the ARP Atlas of Peculiar Galaxies, we always put a challenge for the observers. Look for this, look for that, see if you can see this, see if you can see that. And for this particular galaxy, let me see,
What is the number?
192, I think.
Yeah, it's 192.
Yeah, that object I showed you with the spike that's gone, is ARP 192. And we said, look for the spike, look or image the spike. That was the challenge in the book. And it wasn't too long before one of the imagers, a fellow named Rick Johnson, who some of you may know, is a fabulous and prolific imager. And just a couple of years after our book had been published, he contacted Dennis, my former co-author, and said that the jet wasn't there in his images. Well, this was a little disturbing, a little interesting, but disturbing. And so I went back and I looked at the ARP image, and I looked back at more recent images. And then I started doing contrast enhancements and all kinds of things to try and figure out, is the jet not visible in this more recent image, or what's happening? This led me to talk to Brian Marsden, to Brian Skiff, to Barry Medore, Harold Corwin, just other people. And I said, what's going on here? You know, you can't have a feature like this disappear in, inside 40 years. And so we all kind of pulled together and figured out that it was an asteroid. Brian Marsden, the late Brian Marsden, did a backwards check calculation and found that there was this particular asteroid that had only recently been discovered, or rediscovered, I should say, in Hawaii. And anyway, make a long story short, Brian said, well, it's your asteroid now. So that's what happened.
And
And is the trail curved because it was passing close by the Earth when the picture was taken?
Yeah, if you look at it, it really does look curved, but it's in what I understand, and I don't fully understand this. Well, what I know anyway is that it may have been an emulsion effect on the film itself, the way that the light fell off of the asteroid, and it may have caused this curve. It's very, very slight. In fact, you can almost argue that there's no curve there. When I looked at it, I thought, well, there's a curve, and asteroids don't do that. But we all agreed eventually that it may have been an emulsion effect, but we still don't really know.
I was gonna just try holding it up again. It's this
Oh.
guy right here in the middle.
Yeah.
Yeah. And so, yeah, that's an asteroid trail. And the thing Jeff is leaving out is that is asteroid 8447, Jeff Kanipe.
That's why I married
Yes.
Oh, that's pretty cool.
You are done. Okay.
her.
Okay, let's see, Bill Peters has a question. You're live, Bill. Bill Peters, you can unmute if you like.
Can you hear me?
Now we can.
There you go.
Good.
Hello, Bill. Hello, Bill.
Good, hello. Do you think that most merged galaxies are, most globular clusters are merged small galaxies, and that's the cores that's left over? Excuse me, do you think most globular clusters are small merged galaxies?
It could be that a lot of the large globular clusters, especially the ones that have established orbits and have star streams, could be the nuclei of former dwarf spheroidal galaxies. Whether those were involved in a merger or not is unclear. What is clear is that they are streaming, they're leaving star streams behind. They do have orbits, and they do appear to be interacting with Milky Way, like Centaurus A. And the size and the mass would seem to indicate that it was a former dwarf spheroidal. Whether those were involved in any kind of interactions, I don't know. The thing is that spiral galaxies, when they interact, when spiral galaxies interact and merge, they do form elliptical galaxies. But at what scale does that stop or not? I couldn't tell you. Maybe you can do the research and report back to me.
And speaking of merged galaxies, I have a question for you.
Yeah.
Are irregular galaxies and peculiar galaxies now a merged term?
That's an interesting question and a good question. Irregular galaxies they really have their own class, and they sometimes are disturbed, but they're not merged. They're just irregular galaxies that perhaps were disturbed at some point. The large and small Magellanic Clouds, for instance, are galaxies that probably just flew too close to the Milky Way and got caught into the tidal gravitational tidal forces of our galaxy. And so, yeah, what we're talking about really is delineations that who knows where one ends and one begins. And that's what makes all this interesting. It's why I say, peculiar galaxies, what really makes them peculiar? Everything. They're all peculiar if you get down to some level.
Okay. So Tom Curry doesn't have a microphone, but his question is, with the Spitzer and Chandra telescopes, new views of galaxies in infrared and X-ray, is there a new series of designations for some of the galaxies?
Yes. As far as I know, there are sort of classifications for like X-ray structures and forms, but there's no formalized, no tuning forks, for instance, for these things. it's a no man's land, and you have to cease trying to classify something and begin to try to understand the structures that are inherent with that particular galaxy, whether it is in infrared or X-ray or ultraviolet. I mean, part of the reason I wanted to give this talk is I just wanted to like say, you know, it's not the be end and all. That's the galaxy classification is not the be all and end all. You know, okay, you've got an intermediate barred spiral galaxy, but there's more to it than that. You just can't just say that's what it is and leave it. And I feel like galaxy classification has to be more holistic. How that is, I don't know. I'm not an astronomer, but I just feel like you know, one of the things I've learned about all this is that really astronomers don't know a lot about what they're talking about. They just basically classify things to make it nice and tidy. Like I said, arranging the junk drawer. And of course, there's a whole, you know, field of galaxy morphologists who've done great work, but I think it's just the beginning. And I think there needs to be someone else out there is more brilliant than I is going to have to come up with some answer. I don't know what it is. Good luck to you.
Okay. Yeah, Jack Jones had a comment, doesn't have a microphone. He says, I wish you could autograph my book. So,
well, here, I mean, just do this.
yeah, I'd say
if I ever get down there, I'll autograph your book for you. I'll be happy to.
Or Jack can put it in the mail or something.
I can send you a postcard.
Hey, how about that? tape it in the book.
Just give me your address and I'll send you a postcard. You can stick it in the book.
Okay, let's see. Derek. Okay, Derek, you should be good to talk.
Hello, Tom. Can you hear me?
Yes.
Okay. Hi, Jeff. Thank you. Great, very interesting talk.
Thank you.
I had a question around dark matter as it pertains to peculiar. I guess there's a prevalent theory that with normal galaxies that the reason they don't fly apart is obviously because there's some sort of unseen dark matter that's holding them together, which can be anywhere up to like 80. My understanding is 80 to 85% of the total mass of the galaxy can be actually dark matter.
Yeah.
So given that these peculiars are so oddly shaped and, you know, don't kind of like bear any resemblance to something that would, you know, remotely look like centrifugal force or something, is there a different mechanism or something else that's going on dark matter wise in these galaxies, or we don't know yet?
Well, as I understand, dark matter is something that's pervasive. It's inherent in all galaxies, and it's inherent in even peculiar galaxies or galaxies that are interacting and are merging. So they bring their dark matter with them. And it's a good question you ask, because it's like, what does that do to them? How does that affect them differently? Or how does that affect these peculiars versus how it affects normal galaxies? Another reason why we want to study these abnormal systems. Physics tells us that all these galaxies should have a pool, or should be in the center of a pool of dark matter, and at the center is the galaxy, and the dark matter is the pool surrounding it. And I don't think it's any different with these interacting systems. They bring their dark matter with them. The question is, and this is a thing that I've seen in research in some of the papers, is how dark matter is affecting their morphology over time.
Yeah,
it's a fascinating. You raise a fascinating issue.
Yeah, thank you.
Yes, sir.
And there's one more question. I don't think Dan Beck's online anymore, but he's asked, have any ghost galaxies been observed interacting?
Ghost galaxies.
So,
you know, really, the smaller the galaxy, the less likely it is to be interacting with anything else. But some of these galaxies are so small that they are around larger galaxies. So you can't rule them out either. I mean, you've got to, there are galaxies that are supposed to be, to exist in isolation in space. But it's rare to find one that's not affected by its environment or some inherent problem, some inherent thing that's going on. So I don't know about ghost galaxies, perhaps. I think that again they're subject to the same laws of gravity that the larger galaxies are. They're just smaller, and it's a field that bears scrutiny, I think. So yeah.
Okay, and let's see, Claude put a question in the chat. Claude, you're able to unmute yourself. There you go.
Astronomy magazine article, I think, that was positing the idea that globular clusters were ancient open clusters, which I'm a little dubious about.
Yeah, I would be dubious as well. The globular clusters date back, the oldest ones date back almost to the Big Bang itself. In fact, for a while there, some of the globular clusters were coming in with ages older than the universe. So globular clusters formed very, very early on. Open clusters formed out of giant molecular clouds, mainly in the disk of spiral galaxies, because that's where all star formation took place. So you don't see a lot of globular clusters. Well, you won't see any globular clusters in the disk, but you will see a lot of open clusters because the density waves that pressurize the clouds to collapse and form star clusters. And neither the twain shall meet, I think.
Okay. And as a side note, I asked Tom Palakis, who's working at Lowell part-time,
Yeah.
what he can, how faint of an asteroid can he image? And unfortunately, he said he can only go to about 19.
Oh, well.
So
We'll keep it up. We'll keep the search up.
You're going to need a bigger telescope.
I'm going to need a bigger telescope. Yeah, that's true.
Okay, so I think that clears the Q&A queue. Yeah,
Okay.
thank you for a wonderful talk. And
well, thank you for having me. I've enjoyed this immensely, and got a very perceptive and intelligent club there. So go forth and be brilliant, you guys.
Cool. I'll hand the meeting back over to Gordon.
Okay.
All right. Hey, let's see. Can you guys? Yeah. Okay. Showing up. Had a little glitch here. It said that my video wasn't showing, but I guess everything's going fine now. So Jeff, thanks a lot. Thanks a lot for that. This is definitely a different type of presentation, and this is what we like: is those things that we normally don't hear, normally don't see all the time. So this is definitely a subject that I think everyone really.
Well, because I'm peculiar, so I'm going to pick these peculiar subjects.
There you go.
I got a lot more where that came from.
All right. Well, level, birds of a feather.
Yeah.
So fun. Yeah.
All right. What I want to do right now is remind everybody, all the club members, is to vote. You've got just a couple minutes now before we close this meeting down to vote if the new officers, the list that I was shown, if you're okay with that. So far, we've had 45 yes votes, which is unanimous. So we've had no votes. So no one agreed to fill the open position by a no vote. So I think it's going to be unanimous, although officially it'll be in our December newsletter. So Jeff, thanks again. Thanks again for a great presentation. We really appreciate that. And remember, folks, our next meeting is on the 17th of December. It's our holiday party. And I'm really looking forward to this one, because what we want to do is we want to have you, our audience, not just club members, but the audience too, is send in some little 10-minute presentations about your adventures, your likes, your successes, and your failures. Remember, we learn more from our failures than we do our successes. So let us all know And we should have a fun time. Should have a fun time with having a few of these mini presentations from our membership. So just let me know. You can go into our website, bottom of the first page. It's the president's link. Just let me know, and that you want to be involved in this. I think it's going to be a lot of fun. Going to be a lot of fun. So let's see. Is there any other chats or questions? Nope. Tom, you got anything before we close down?
Nope.
No, I don't think anything else from our leadership team has anything else. All right, so everyone, I will give the usual countdown to close the meeting.
Happy Thanksgiving, everybody.
Oh, yes.
Hey, all right,
Happy Thanksgiving.
all right, that's a good comment. Love that. Okay, 3, 2, 1. Bye, everybody.
Bye.
Bye.